Hi guys. Now I'm gonna start this problem. 75 sort color, a lot of likes and small dislikes. And Yahoo, Amazon, Apple, and a lot of other companies and a lot. So it's kind of old problem, but still, still it has some popularity. And then so let's start. Given an array of nums with n objects colored red, white, blue, so 3 colors, sort them in place so that objects of the same color are adjacent with the colors in the order red, white, blue. So these are 0, 1, 2. You must solve this problem without using the library sort function. Okay. So for this, this is array problem. So first thing I can think is we should not use a sort. So one way is to use min heap. By using min heap, this problem is pretty easy. We can just push numbers into min heap and then pop numbers into min heap. And then the other way around is that since there is only 3 numbers, we can count each number and then create and then in this case 0 is 2, so we can push 0 into here. Then 1 is 2, so 1 1. 2 is 2, so 2 2. So this is pretty easy. Another way around is that we can have a pointer in here. Let's say this pointer, and then this pointer in here. So how about here? So here we have 0 and 2, so we switch this to like this, and so this is done. So we move forward, and this is 2, so we move forward, and then this is 0, so we are okay. So here we move forward like this until they meet each other. But would that work always? So for example, what if we have some number like this? Here both are 1, so it moves until we meet 1. So we made 0, so we change it. So this has Then the next one is 0, so we are okay. So this is 3n. I mean, so in between here, when there is no 0, and then both meet again. And then now we know that we have 2, 0. We start from here, 1, 2. So we switch this and switch this. Then we move this, and then they are adjacent. So we know that one is done. And then we start from this and this, which are same. So we're done. So this is 3n. Not bad. So since this is an object with color, this approach is better than count, because in case of count is, well, it returns correct number, but not sure whether that's really the way we solve that, because we lose all the attribute and we just keep the count color. So let's solve this with this approach. So we're gonna have place usually 0 from 0, and then nums that size -1. This is always nums that size -1, and then this will return next nums. So starting index from 0, and then starting index is now this one. Can do is now 1. Then after doing this, so we're gonna make auto place int color int starting index, right? And then we're gonna use nums. So int end index, let's say k1. End index. To pointer up approach. So the way we are gonna do that is increase, decrease. Check if si is color. If not, if so, increase si. If not, check if ed is color. So switch. If not, decrease EI while as it's not color. Switch. So while, let me rewrite this later, and gonna increase while color gonna increase SI, and then SI, so we need to check the boundary of SI is within not color, gonna decrease EI. So now we have both the same, both the same. Where is EI? Oh, here. EI and the index, which is nums size minus 1. So SI should be smaller than EI. If they are same, then you don't need to do anything, right? If they are same, and then the same, that element might be color or not, but in both cases you don't need to do anything, right? So something like this, and then switch. So nums SI and temp, and then nums.SI, nums.EI, and then nums.EI equals what we can call swap. So SI is not color, and then after swapping both, we need to increase SI, we need to decrease EI. So the thing is, we have 0, 1. We have, for example, 0, 1 in the array, and SI is here, and EI is pointing to here. So in while statement, this is not color, so si is 0 and 0 is color, so this is false when, let's say, the color is 0. So this is si, and ei, this is different from color. Yes, no, this is color, so we minus, so we, and then here we switch both. So now this is 0, this is 1. And then the next round, Si is still smaller than Ei, and then we increase the Si. So now Si is here. And while, but from here, Ei is now the same. So if we have this condition, we swap, but we are not gonna swap, right? So now both are here, and then Si we need to return Si. Right? So the next round here, we're gonna check 1, right? So now Ei is here and Si is here. Both are pointing to 1. So here, oh, this condition does not met. So we return Si. Yeah. And then we check this condition 4 times. Oh my god. Maybe we can just break. So let's check whether this works. Here 2, 0, 2. So length is larger than 1. So initially we can have this, or we can have this, or we can have something like this, or this, or some complex one. So if 0 and if 0 is the 1, then starting index 0, 0, 0, So we are not sure whether we have 0. So there is a case, so 0 or 1, or for example like 2. 0. So here, this one will be increased. So if in case of 0, this is starting index, and then this I think we better have this condition in here. Yeah. Because yeah, it seems kind of bulky, but then when there is only one, then this one or this one, you know, can be different, can be same, so it will just go to S1. S1 is 0, right? So nothing happened, and then the second one, starting index is 0, and then we would try to find 0, but nothing happened, so we just return num. But in case of 2, it's same, right? And what if 0, 1, or 1, 2, or 2, 1? Two number. So in case of 0, 1, starting index is here, and ending index is here, in case of 0, 1. So starting index, we found the starting index 0, so ending index is here, and then because of this condition, while loop will be break, and this will be break, and this will be break, so we're gonna return 1. And then here we try to find 1, but then the index are same, so nothing happened, right? So this is okay. And then what about this one? So starting, ending here. So 0, we first try to find the 0, so we're gonna increase starting index up to here. And then nothing happened. No. So starting index is this one, and ending index will be decreased. So ending index will be here, and nothing happened. So return starting index. Right? And then we will try to find 1. And then starting index, nothing happened. Ending index is 1. Let's think about 0 case again. So num ei is different from 0, right? So we're gonna decrease here, okay? And in case of 1, in here, num 0, so num 0 is same with the color, same, right? something is wrong. So starting, this is correct, and this should be this. No, this should find, while num is different color, we're gonna decrease. So here we are not gonna decrease, right? Because we found. And then we switch these by here, and then next round, this one is same with color, so S will be increased into here, right? And then, yeah, so this works. Yeah, so I think this will work. No, there's no return. Okay, so the easiest way is count. One pass. The problem is Dutch national flag problem and was first proposed by Edgar Dijkstra. Okay. Either move current. The idea of solution is to move current pointer along the array through swap. Rightmost boundary of 0. Initialize P01 during the algorithm execution. What is this notation? What is this notation? Okay, so P0. What's current? Oh, current pointer. So, okay, current is 2, some non-current and non-P2. Okay, P2. Okay. proceed both. And 2, so switch and proceed 1 P2 and current. When we stop current, when we meet 2, trick question or just to understand how a candidate think. So in my case, what I did it was this one is one pass, but mine is 2 pass actually. And then in 2 pass solution, what I did was first try to find 0 from the end and move it to the front, and then try to find 1 and move to front. But this smart Dijkstra guy solved this with a 3-pointer, P0 and P1. P0 is boundary of okay. Yeah. what's low and what's mid, what's high. Mid is unknown area that we must evaluate. So what if this is 1? Like 1, 0, 2, 1, 1, 0. So P0 is here, current is here, and then P1 is here. So what happened in the case? While current P2 num P0 num current so else current plus 1, so current plus 1, and then now 0, so current will be num current is now P0. Switch this. Okay. The next turn, this is 1, so move again. So now 2, and switch this and this. Now 0. Oh, this was okay. So here going to 0. So this was, both are switched. Move this, and then current is move again. Wow, this is really difficult. How do we know we should move current? Why current? Why do we need to move current? I don't know. So now this is switched, and then P0 is decreased, P1, P2 is decreased, but current is not moving in this case. So when you find 0, current was 0, and then previous one could be could be 1. so difficult. I will use this my solution if I encounter this in an interview. This is so difficult. Okay, so let me finish.